Hi, welcome to my video on the inverse of a parabola, part 6. This video is designed as to create an extra problem, again to increase your understanding of the inverse of a parabola. Find the x and y intercepts of the inverse of f of x equals x minus 3 all squared plus 1. So notice that this is y equals x minus 3 all squared plus 1. So it's a parabola, and the vertex of the parabola, x is 3, opposite. So when I put a 3 in here, you get a 0. 0 squared is 0, so y is 1. So that's the vertex. And because it's a parabola, the domain of a parabola is real numbers, and the range of this parabola is that y is again, it's a plus, so it's going up, so y is greater than or equal to 1. So let's find the inverse. We want the x and y intercepts of the inverse of this parabola. So we made f of x a y, so change the y to an x and an x to a y. Now we have to solve for y, so x minus 1, y minus 3 squared, so plus 1 becomes a minus 1. So this becomes plus or minus the square root of x minus 1 equals the square root of y minus 3 all squared is y minus 3. So y is equal to plus or minus the root of x minus 1 plus 3. So this is the f of negative 1x, so this is the inverse. So it's a plus or minus the root of x minus 1 plus 3. So this parabola, if you do a quick sketch of it, just think about it. This parabola has a vertex of 3, 1, and x is 3, y is 1, and it opens up. So that means that the parabola is doing this. So its inverse, and I'll use the red for the inverse, would be, because it's moving up, the inverse of this is x is, that's 3, 1, so it's 1, 3. So x is 1, y is 3. The inverse is right here, and it's moving. When you do the reflection of the line y equals x, the inverse moves this way. So there's his inverse. So it makes sense that the vertex of this one, either one of these two, x is 1, y is 3. So the inverse of 3, 1 is 1, 3. But this parabola is made up of a right side and a left side. So that means if you changed f to the negative 1 to a y, you get y equals the positive of x minus 1, square root of x minus 1 plus 3, or it's made up of y equals the negative square root of x minus 1 plus 3. So we have two parts. But according to the graph, notice that the inverse is this has no x-intercept or no y-intercept. But this part here has, because the vertex is here moving to the right, this part of the vertex has an x-intercept. So there's no x-intercept or y-intercept on the upper part. That's the plus. But there is no y-intercept on this part, because this is the part that's going down. So what happens, we can only get an x-intercept. But algebraically, let's determine that. Let's see. So we have this. So to get the x-intercept, we let y equal 0. So you take this equation and you let y equal 0. Okay, there it is. That means the square root of x minus 1, negative 3 plus 3 moves over to become a minus. So the square root of x minus 3 is negative 1. The square root of a number is always positive. So therefore, there's no x. Oh, I said no. no, let's put an X here. There's no, sorry about that, there's no x-intercept. So let's look at the y-intercept. The y-intercept is when we let x equals 0. So you take the equation and you go y equals square root of 0 minus 1 plus 3. So y equals the square root of a negative 1 plus 3. And the square root of a negative 1, square root of 1 is 1. Is 1, and the square root of a negative number is I, so that's an I plus 3. So that's imaginary, so there's no real intercepts, so there's no y-intercept. So there's no y-intercept. No y-intercept. So algebraically, I'm explaining it by doing the zeros and working it out, which is from the graph. We knew that part of the inverse going up, it's going up, so it has no y-intercept, it has no x-intercept. So let's look at the other part. And we want to get the x-intercept. X-intercept, again, for this one, is when you let y equals 0. So we let y equals 0, so we get 0 equals negative x minus 1 plus 3. So because that's negative, I'll move it this side, make it positive, and let the 3 stay there. So I'll do the square of each side, because I got a root. So I get an x minus 1 equals 9. So x equals 9 plus 1, x is 10. So that means that this point is when y is 0, x is 10. When y is 0, x is 10. So that's, if you drew the graph, that would be way over here. There it is right there. So that makes sense. So that's going to be the point 10, comma 0, which makes sense. And let's find the y-intercept. The y-intercept is when you let x equals 0. So it's the same as this. You're going to go through the, when you let x equals 0, it's going to work out like this, no matter if it's a plus or a minus. So you got the equation, y equals negative root x minus 1 plus 3. And you got x is equal to 0, so you get the negative of 0 minus 1 plus 3. So y equals the negative of the root of a negative 1 plus 3. So y equals, that's a negative. The square root of 1 is an I. And the square root of a negative number is an I. And the square root of 1 is 1. So it's a 1i, negative 1i plus 3. Again, there's no y-intercept. So algebraically, I worked it out by letting the x and y is equal 0 and working the end problem out. Or if you graph the original parabola, graphed as inverse, you'll see how these answers are fitting with the explanation. So the geometry is fitting in with the algebra to find the x and the y-intercepts of the inverse. A problem that I made up just to do some extra thinking. And again, click on the like button if you like my video, and the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube, YouTube channel called Math Fully Explained. And there, notice Math Fully Explained is one word. You'll find all the topics that I have my videos on. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.